Okay, number 67 is asking us to come up with a linear approximation for e to the negative 0.012 power. So, a couple things we need to do right here. We need to set up a function right here, f of x, that can be used to model this. So since this is e to a weird power, we're just going to go with e to the x. And then we need an a value right here that will be easily evaluatable. I don't think that's a word, but easy to evaluate in this function right here. That's very close to that goofy number right there. So we're just going to go with a is equal to 0. So that's where we're at there, guys. We need f of a. So f of 0 right here is just going to become e to the 0 power, which is 1. So that means the center of our linearization, or our point of tangency, is going to be 0, 1. And then, I'm sorry, that is not f prime of 0. That is just f of 0, my mistake. And then we need, here we go, f prime of x. The general derivative of e to the x is just going to be e to the x. And then we need to evaluate that derivative at this a value here. So f prime of 0 is just going to be e to the 0 power, which is 1. And that is the slope of our tangent. So with our point of tangency and the slope of our tangent, we just need to put all this together. This one worked out pretty nicely and easily right here, I think. So here we go, guys. In point slope form, it's going to be y minus 1 is equal to your slope, 1, times x minus 0. So this actually worked out really nicely. This is just going to be y equals, that's just going to be an x there, and then a plus 1 at the end, and there is your linear function. So I think I can fit all this on one spot right here. What we really want to know is, hey, what is the value of f of negative 0.012? And that value should be very close to the value of L of negative 0.012. So we're just going to put that in for x, negative 0.012, and add a 1 to that. And that should get us a value of 0 point, and I think that's going to be a 988 if I'm not mistaken, and that should be our answer. So now I'm just kind of curious to go to my calculator and plug that in and see how close we actually got on this one right here. So if we were going to evaluate e to the negative 0.012 power, we get 0.988071 blah blah blah. So my answer of 0.988 seems pretty good to me. Okay. So that is how we do number 67.